Good morning, students. In previous class, we were discussing about software quality metrics. Have you gone through the PPT? Any doubts?
Good morning. No, ma'am.
Yeah, good morning. Naveen, slide is
No, ma'am, not yet. Now it is visible, ma'am.
okay. What we discussed in the previous class. So we started with the topic software metrics.
Yes, ma'am.
We were discussing about the various parameters and elements of software metrics. Then we discussed scope of the software measures, measurement basics, representation theory and scales, meaningfulness, and what to measure and how to measure. The GQM technique then we discussed. Then the control flow starting. We discussed two GQM techniques. Is it correct?
Yes, ma'am.
Yeah. Today's class we will discuss again GQM technique, then control flow factors, product quality metrics, and defect density, customer problems, customer satisfaction and function point, metrics for software maintenance, in process quality metrics. Metrics. It is a quantitative process. We are using the quality standards to measure the software quality, and the software metrics affects the quality of the software, and it should be implemented in each and every stage of our software development process. If you take the definition of software metrics, it includes the elements such as customer satisfaction, supplier performance, manufacturing defects, and cycle times, many other internal and external process activities. So it is a framework which represents the quality indicators and performance parameters. And the quality can be measured in terms of product, project, as well as process. So we have to measure we will go for the product characteristics once the product is developed, and process characteristics will be considered during the process of software development. And project characteristics, we have to follow the methods, rules and regulations, the quality parameters, and the best practices during the project development itself. Then we discussed the scope of software metrics. The scope of the metrics includes the cost parameters, productivity, data collection, quality models, and the structural complexity of the software. If you take the A to Z of software metrics, we have a number of software quality standards and measures, like say the agile principles, cost and estimates, forecasting techniques, KPIs, lines of code. Like that, we have a number of open source tools as well as the techniques and the quality standards to measure the software quality. I think then we discussed objectives of software measurement in terms of manager, in terms of engineer. So the quality differs from one person to another person based on their role and responsibility. So in a manager's perspective, he will consider about the cost, how many staffs we need, and how many lines of code we are going to create, whether the software is useful to the society as well as the satisfaction level of the software. In engineer's point of view, we'll consider how the software is testable and how we can find out the faults and the process goals, how we can improvise the content in future. And then we discussed the static metrics and dynamic metrics. So the static metrics are used during the analysis and design stage, and the dynamic metrics we use during the implementation and maintenance stage. The software quality metrics can be in-process quality metrics as well as maintenance quality metrics. So the in-process quality metrics is a separate topic in our syllabus. Here in-process quality metrics, it totally focuses on defect density and machine testing, testability. So these two parameters will come under mean time of failure. So how long it takes the software to get failure. So if you have a more number of defects, then it will take less time to. If your software is free from bugs and errors, it will take long time to get infected. If you have more bugs, then the density will be very high. So in-process quality metrics deals with how long it takes. Mean time to failure. Mean time to failure in the sense, say whether it will create the issues and problems within 6 months or 1 year, like that. If you take the maintenance quality metrics, so it is based on the fixture of backlog and backlog measurement index. So after the testing, we will create the log file. So in the backlog file, based on the parameters, we'll evaluate the maintenance quality metrics. Then what is the defect density means? The defect density can be defined as the defect arrival rate and the machine pattern during the machine testing. So and the product quality metrics is based on the customer problems, and in with respect to it's based on the phased defect removal pattern. And in case of maintenance quality metrics, it's based on percent. So any doubt with respect to this particular slide? Here we discuss based on the product quality metrics, in-process quality metrics, and maintenance quality metrics. So the product quality metrics is based on how we are going to measure the product once the product is developed. In-process quality metrics is what are the measures we are taking into consideration during the testing phase. And maintenance quality metrics is once we started using, once the software is deployed, how we are going to maintain without any bugs and errors by using the antivirus, firewalls, and other softwares. So you got the idea, the main difference between product quality, in-process quality, and maintenance quality. Any doubt?
No, ma'am.
Anyhow, we are going to discuss in-process quality metrics in detail. Last topic.
Okay.
And if you take the in-process quality metrics, it's we are having the techniques like phase-based defect removal techniques, defect removal effectiveness, defect density during testing, and defect arrival pattern. So these are the elements which are used to measure and eliminate the in-process bugs. Phase-based defect removal in the sense, during each phase, during each development, software development lifecycle phase itself, we will go for the metrics. And defect removal effectiveness means once a defect comes, then we need to apply the techniques to eliminate the defects. If you take defect density, so it is based on a measurement, how many defects we are finding, how often we are getting the defects, and how we can rectify. So based on the density of the defects, we need to go for the removal techniques. And the defects arrival pattern in the sense, in which pattern or in which form the defects we are getting. Say while executing a particular function, we are getting the defect, or during installation time, or during a backup stage, or during a startup state. So based on the pattern, we will identify the pattern of defects. Then accordingly, we will apply the technique to remove the defects. Then we discussed, I think these topics we already discussed in the previous class. So once again, I am revising, and we will finish this module today. So if you have the beginning to the end, because each and every topic is interrelated with each other. So if you remove the previous topics and concepts, then only you can easily understand the new topics.
Okay.
Then we discussed what is software metrics, the definition, what are the elements and standards used for software metrics. So it is a standard of measure of degree to which a software system or process possesses more property. Then why we need software metrics means it is useful for evaluating the health, quality and progress of the software testing effect. So if you have the metric for evaluating the software, then we can easily explain, and we can increase the brand value. We can quantify, explain and demonstrate the software quality. To take the software metrics and its characteristics, it's based on, it is a measure of software characteristics which are measurable or countable. So the metrics are countable one, and it's having its own parameters. So the metrics is based on the value or cost, based on the quality or quantity. To take the quality, we have reliability and defects. How reliable your software is and how much defect we are facing during the processing. And the quantity in the sense, the size of the defects and functionality of your software. And if you take the cost factor, we have personal, resources and complexity. Personal is based on the time and money, and resources are based on hardware and software resources, what we are using along with the software. And if you take the complexity, it is based on the environmental constraints and problem difficulty. So if your software is having less coherence and more coupling, coherence and less coupling, then the complexity will automatically decrease. Then we discussed the various elements which are used to measure the test effectiveness ratio, requirements stability. So we have formulas for each and everything. So based on the formulas, we are calculating the programmer productivity. So the programmer productivity can be calculated based on the lines of code produced divided by the person months of effect. How many lines of code a person or programmer is creating per day, and how long it takes for a developer to complete the project. The same way, if you take the system spoilage, it's based on the value of effort spent fixing the faults divided by the total project effort. So like that, we are evaluating and measuring the various quality metrics. Then our next topic is classification of software metrics. So the software metrics can be classified into product metrics and process metrics. Within product metrics, we have static and dynamic components. Under static only, we have various aspects like size metrics, design metrics, control flow metrics. Here, the control flow metrics is a separate topic in your syllabus. Information metrics, weighted metrics, data structures metrics, and software science metrics. Under the size metrics, we have the various elements like lines of code, token count, function code. So based on the lines of count, how many, if there are 100 lines of code in your project, out of 100 lines of code, only 10 lines are having the defects and logical errors. Then based on that value, we'll go for the efficiency. Then under the control flow metrics, we will take the various control flow parameters like the constraints as well as the looping statements, iterative statements, how many functions are there. So based on the number of functions, we will calculate the control flow metrics. So any doubts so far?
No, ma'am.
I think next week you will be having internal assessment 2. Okay. So it's based on module 3 and 4. How many modules other subjects they covered?
Java is completely covered, ma'am. All 5 modules.
Okay. Lab completely covered.
Lab also is covered. We are doing mini projects in the lab. Other subjects, 3.5 is completed. 3.5.
Who is taking neuromorphic?
Manjunath sir itself.
Okay. How many modules covered?
That is 3.5, ma'am. 3.5 modules completed.
Software engineering?
Software engineering also same, ma'am. 3.5.
Okay.
Max only it is 3. Sir is doing 3rd module.
Okay. Research methodology, how many modules?
It's also 3
Research.
modules.
Okay. And PCL, you got any material?
No, ma'am.
Okay, now the PCL, we have for all, PCL is common for all the branches like food technology, mechanical, civil, EEC, as well as computer science and other specialization subjects. So now they appointed one PCL coordinator for all the MTech branches, all the 11 MTech branches. I think Sandeep Rao sir is the coordinator. Sir will be sharing the material, the instructions. So before sir sharing the data, it's like almost a mini project. Anyhow, the MTech guidelines will be different from the BTech guidelines. So the thing is, you need to do some project, mini project. The project can be interdisciplinary, or so if you have any friends with other departments, you can form a team. You can start working on the mini project. So it's like you have to submit a mini project report. For Java, you are doing a mini project now.
Yes, ma'am.
Voice is clear, or my voice is clear?
It's clear, ma'am.
Yes, ma'am.
Okay. So same as mini project for Java, you start, you identify a topic for, because it takes long time for getting the instructions from the PCL coordinators. So according to BTech level, we have the same methodology, the same evaluation techniques will be used. So better you start identify a topic, you work on the topic. Okay.
Okay, ma'am. Yeah.
So because if you wait for almost we have another 1 month time only. So you all of you, all the three of you, you identify one topic based on the latest techniques. It can be an IoT based or cybersecurity based or artificial intelligence or deep learning technique based.
Okay.
If you know any friends from other departments, you can form a team. Then now you have to go through some latest papers and concepts. You identify the problem statement, then you identify the research gap in the existing method. You propose a method, and you need to submit and report on that. Okay.
Okay.
Anyhow, I will share the guidelines after getting the instruction from the PCL coordinator for MTech. I think now Sandeep Rao sir. Okay.
Okay.
So our next topic is measurement basics. Here we are going to discuss what is measurement, what are the basic tools we are using for measurement. So the basic measurement tools are same as what we are using in our real-time scenario. So we are using various measurement tools now for measuring the liquids. We are using liters. So if you are buying an oil, you will buy 1 liter oil, 2 liters oil, milk and other products. The same way, if you are buying vegetables and fruits, what we will do? We will go in kgs, 1 kg, 2 kg like that. And if you are measuring the distance, so if you are buying a plot, we will buy an 1 ground, 2 ground. So we will say the measurement 2,400 feet is 1 ground. So like that, we are measuring in kilometers, meters, or feet and inches, or we will use other tools like miles, like that. So the same measurement tools, basic measurement tools, what we are using for liquid items, quantitative, qualitative products, the same tools can be used in software metrics also. Then we discussed in the representation theory how the measurements are represented. What is the basic logic behind representation theory, like scales, meaningfulness. Then how to measure and what to measure. These are the topics we discussed. In general, we are using the International System of Units. Is the world's most widely used system of measurement. So we are using the SI units. And precision is the smallest unit. So if you go with minor precisions, say if you are buying gold and all, we are using the gram, milligram. Or if you are going for diamond, we'll use carats. The same way, if costly products, we are using the precision to the 1 point, 2 point, 3 point. That is nanoscale also, milliscale and microscale also we are using. That is called precision scale. And the range is the maximum length an instrument can measure. So range means say using some electric weight machines, they can measure up to 25 kgs. Some machines will measure up to 10 kgs. So like that, we have the range for every measurement technique. So those are the basic aspects of measurement. So what is a normal scale means? A scale that categorizes the items. So based on the type of product, based on the category of the product, we are using different scales. So if it is liquid items, we are using different scale. If it is distance, we are using meters and kilometers. If it is products, we are going for kgs. And what is an ordinal scale means? The scale that categorizes and orders the items. So we are using the ordinal scale. So the same category. What is interval scale means? We'll give the range. If you get less than 35, they will be in D grade. If you get more than 40 to 60, they will say second class. 60 to 75, first class. Above 75, they will say first class with a distinction. So we have that range scale. If you will say the A grade, B grade, C grade, so that is called interval scale. And the ratio scale means the percentage. So if you are using say we are using like 60%, 70% ranking, first rank, second rank, like that. So these are the different forms of using measurement: nominal scale, ordinal scale, interval scale, and ratio scale. And if you take the types of measurement, we have nominal, ordinal, interval, and ratio. So any doubt with the basic fundamental software metrics measurement tools? Nominal means it is used for measuring the unordered categories. Ordinal scale is used for categories with intervals not be measured in equal. And interval scale is used to measure from the ordinary arbitrary region 0 to a particular limit. And the ratio is used to calculate the overall out of 100, what is their position. So we'll say ratio means it is out of 100. And then we discussed the software components for measurement. So the measurement is having its own attributes and entities. So we are using the specifications, designs, code, test data, processes, testing, resource kernel, teams. So these are these entities are used to measure the attributes. Say for example, the products are measured based on internal parameters as well as external attributes. If you say the code, based on code, we will say that take the size of the code, whether the software, the code can be reused, or it is having the modularity concepts, how the coupling, whether the coupling is very high or low, functionalities, how many functions it is performing, algorithmic complexity. Algorithmic complexity is measured in terms of time and space complexity, how much time it takes to process, how much memory it occupies during the runtime. So the code can be measured based on these internal attributes. These internal attributes are part of the code. And the external attributes like reliability, usability, and maintainability. Whether it is a reliable software, user-friendly one, whether it is a reliable one, a branded code, or it is already certified or not. So we can measure anything with respect to software based on the internal attributes and external attributes based on the product entities. So entities means the various elements of your software. And the software will have its own internal parameters, that is called internal attributes. The software will exhibit some external parameters, that is called external attributes. If you take what to measure, how we are measuring, and how to measure means we are using the measurement in everyday activities of our life. Say we are measuring we are having marks, grades, timing, buying any product, everything is measured and sold. The cost is associated with the measurement parameter. There too much reliance on ancestral evidences. Try out products and you are improve the productivity by 50%. Say the component cost of projects are not qualified or understood. So the software engineering, if you are going for testing, the software testing process is totally based on the software metrics, and the metrics are measured in terms of various aspects of your software. Say the major aspects are user-friendly, reliable, maintainable, and it is a quantifiable entity. So the next comes the topic called GQM techniques. It is a GQM technique. And then we will discuss the control flow structures and product quality metrics. So as we discussed in the previous class, GQM is based on goals, 3 parameters. Goals, questions, and metrics. So each testing process is associated with its goal. What purpose we are conducting the testing? What is the goal of the testing process? The software measurement process is identified. Based on the goal, we'll raise a number of questions. And for each question, we will use some software quality metric to measure and get the answer for the question. So that is called GQM technique, where G stands for goal, Q stands for questions, and M stands for metrics. You got the idea what is GQM technique? So in this particular unit, GQM technique is an important topic. Module 3, GQM is an important topic. GQM means G means goal, Q means questions, and M means metrics. So what is goal means? While performing the software metric, we'll have there is an aim or goal associated with each and every measurement process. So that is taken as we'll write down the goal of the software measurement process. And to get the answer for the particular goal, we'll have a number of questions. Through the questions answer, we can get the answer for the goal. Say for example, evaluate effectiveness of coding standard. So we have a software, we need to evaluate the effectiveness of our software. The answer for the goal is what is using standard, which standard we are going to use, and what is coder productivity, which code, how the productivity of the code is measured, and what is code quality, whether the quality of the code is as per the norms or not, whether the high standard instructions are used, the cost, time, space, complexity is less or not. So these are the 3 questions with respect to the goal. And the answers for the first question is who is using the standard. So the standard is used by proportion of coders using standard and using language. The standard is based on which type of code we are using and which language. If you go for Python code, it may be more efficient. If you go for C++, the efficiency will be somewhat less. So the code standard is measured based on the language used and based on the standard of instructions. The same way, what is coder productivity? Say if the coder programming developer is experienced person, he can, if he has the previous experience, he can generate more lines of code. So how many lines of code he is creating per day, or how many lines of code he is writing within 1 month. So that is called coder productivity. Here the experience of the coders with the standard, with the language, with the environment, etc. So whether the coder if the coder may be experienced person, but he may not have the experience with the particular language. So he may be very strong in C++, but he may not know the Python or Java code. So how he is familiar with the language, how he is familiar with the domain. So he may written so many projects for banking sector. So he may not have the experience with the airline reservation project, or he may not have experience with online trading projects. So the experience of the coders is measured in terms of the standard of the coder and the language used and the environment, in which environment or domain he is working. And what is code quality means? The code quality is based on code effect, errors, how many size of the functions, line of code, function points, etc. So like that, we'll fix a goal for every software metric. A number of questions will be raised to get the answer for the goal, and the answers for the questions will give you the metrics. So based on the answers, we'll go for the corresponding metrics. So this is called GQM technique. Say for example, they taken an example for to explain the concept of GQM technique. They taken the example of AT&T goals and metrics project. These kind of measurement techniques are previously used in TQM, total quality management. So the same techniques are followed in software metrics also. I think we might have used. Am I audible to you?
Yes, ma'am.
Yes, ma'am.
So in the total quality management, we were using the techniques like ISO standards, IEEE standards, the same way the GQM techniques and COCOMO model. They are all the traditional typical models used along with the products, especially in the automobile sector as well as in the chip manufacturing sectors. So the same techniques are modified according to the software engineering as well as software metrics. So here we are taking the AT&T Bell Labs software GQM model. So here they are taking the questions. So the goal is to identify the examples of AT&T goals, questions, and metrics. So here the goal is creating a plan, project plan, creating and monitoring the control activities, and improving the existing activities so that we can improvise the performance and efficiency. So if you take the goal of plan, we are raising the questions like how much does the inspection process cost? So for creating the plan, how much we need to spend and how much calendar times does the inspection process takes. So for the plan activity itself, we like to identify the cost of the plan and time we need to execute the plan. These are the two questions. The answers for those two questions are average effect per kilo lines of code. So how much effort and time we need to spend for a kilo means 100 lines of code, how much time and how much cost we are spending, and percentage of re-inspections. So if you are going for inspections and re-inspections to evaluate the efficiency, how much time and cost we need to spend. The same way average effort for kilo lines of code and total kilo lines of code inspected. So the goal is for evaluating the plan, and the plan questions are how much time we need, how much cost we need to spend. The answers for the here the measurement techniques used to evaluate the cost is, we will take the kilo lines of code. It means 100 lines of code in your project. For 100 lines of code, how much time we need to spend, how much cost we need to spend. The same way if you are going for inspection as well as testing, for the inspection process, how much time and cost we need to spend. The same way to improvise the existing process, what are the questions means, how effective is the inspection process. So we are conducting so many inspections, how each and every inspection is effective, useful for improvising the process. How we can measure the improvement means defect removal efficiency. So if there is some existing defects in our process, we have to identify and eliminate the defects. So the defect removal efficiency is the method The same way, average faults detected per kilo lines of code, average inspection rate and average preparation rate, average lines of code inspected. So these are the answers or measurement techniques which need to be followed to improvise the goal. The same way, what is the productivity of the inspection process means average effect per fault detected, inspection rate, preparation rate, lines of code inspected. So you got the idea what is GQM technique? Any doubt?
Yes, ma'am. No doubt.
Not yet, ma'am.
So the next topic is measurement and process improvement. How we can improvise the process means, so they are showing in software engineering institute level process maturity model. So here, so they are taking and standard institute level process maturity model. It's having levels, level 1, level 2, level 3, and level 5. So in level 1, we are taking the initial steps. So the initial steps are based on the project management and process discipline. The level 2 is repeatable activities like process definitions and engineering management. Level 3 is defined processes and quality management. Level 4 is managed one. Here we use continuous process improvement activities and change management process. So we will start the process with initial state, then it goes to the repeatable state, then it goes to the defined states, then managed state and optimized state. So through the measurement process, we are moving from initial state to the optimized state. Optimized in the sense, we will take the existing process, we will identify the solutions available for improvising the content. From the available n number of solutions, we need to identify an optimal solution, which can give you the maximum result. So the measurement process improvement is starting from the initial state to the defined state, then it moves to the optimized state. Optimized state is the state which gives you the optimal or the more efficient result. And how the measurement and process improvement can be attained means, so it's having 5 levels. So we've taken the first level. It is a measurement level, or we will call it as the initial state, where it provides the baseline for comparison to improve process and product. So we'll take all the parameters with respect to the process, the baseline aspects. Here we will consider all the aspects so that we can improve the process as well as the product. The level 2 is measurement from focus on project management. So here we will consider all the measurement parameters, how we can measure the existing system and how it can be improvised. Level 3 measures the intermediate and final product produced during the development. So say if you are, we have the life cycle stages now, analysis, design, development, coding and testing. So each and every stage itself, we have to follow some measurement method so that the final product will not have much defects. And if you take the level 4, it captures the characteristics of development process to control activities of individual processes. Here we will capture all the development activities. So in each stage, we need to apply different techniques so that, say, we cannot apply the same technique or best practices in the same level. So during the analysis stage, the steps will be different. During the coding stage, it will be different. During the deployment state, the techniques should be different. And if you take the level 5, measurement allows to provide feedback for dynamically changing the process during the development process. So here during the level 5, that is as we discussed, it is optimized state now. During the optimized state, we have to choose the best optimal solution as well as feedback mechanism. We will give the product to the end users or the third party testing people so that they will evaluate our product and they will give the feedback about the process. And in the 5th level, optimizing level, it is based on the change management and continuous improvement process. So during change management, your project should be in a position to adapt to new changing environment. You should have the option for adding and deleting the necessary things in your project. So this is the measurement and process improvement with respect to software metrics. Measurement and process improvement is based on 5 levels. The first level is called initial level, second level is repeatable level, third one defined, fourth one managed, fifth one optimized one. Any doubt?
No, ma'am.
Okay, I will share. So these are the some of the references, YouTube reference with respect to the software quality metrics. I will upload the PPT. You can go through the content. And I think I have already uploaded the textbook and reference books now in Google Classroom. You have 2 textbook and 2 reference books. I think I already uploaded. I will check it out, and this material is prepared based on the textbook. So far we discussed the following topics. You go through the content. If you have any doubt, you ask me in the next class. Okay. Any difficulty in understanding the concepts, Rahul? Have you gone through the module 1, 2?
No, ma'am.
Gone through the modules 1 and module 2. I have already uploaded the Zoom video recordings also. You OIT 1, that is internal assessment 1 you taken.
No.
Okay, you go through the content. If you have any doubt, ask me. I think we have covered the topics of module 3 as well as module 4. Number of slides. I think in first module we had more than 150 slides. Second module also we had more than 120 slides. So I don't want to give you much more slides. So anyhow, the topics are self-explanatory. So I reduced the number of slides in module 4. So if you want any further reading, if you want additional material, I will upload one more material also, a reference material for module 3. Okay. So if you cannot understand any topic properly, I will give you one more reference material for module 3 with respect to other software metrics techniques for further reading. But the material is covered as per the syllabus only. So if you go through. Okay, any other doubts?
No.
Shall I end the class? I think it's in between cut.
Yeah.
Or Rahul, if you have any doubt, you go through the material and you ask me tomorrow. I will take you revision class for module 3 and 4 for you. Okay.
Okay, ma'am.
Okay. Shall I end the class?
Okay, ma'am.
Yeah, okay.